Here's a topic that sometimes confuses people a little bit. What's the difference between K and Q? Simply put, K is something you can look up in a table. Q tells you where you're at right now. So usually what we'll do is we'll say, okay, I'm going to have these concentrations and I have an unknown concentration. And I'm going to let it go to equilibrium. That's when you're going to use K. If you're calculating a new condition, that's when you're going to use Q. The reaction quotient is what you're calculating to figure out where you're at. Now, that means that you are almost certainly not at equilibrium. It is possible that you have exactly the same thing, but I seriously doubt it. I mean, you could add a little bit of reactant and a little bit of product that totally leaves you there. I'm not going to say it's impossible, but it's almost never going to be. So Q is not for equilibrium conditions. That's going to be something like in the last problem when we actually dropped some sodium chloride into an existing solution and saw Le Chatelier's principle take over. Now, that said, if we compare Q to K, that should tell us which direction the reaction is going to go. So what I want to do is over here, I'm just going to set up a real quick example of a K or a Q, whichever way you want to think of it. We're going to have our concentrations. I'm not going to worry about having coefficients up here in powers. And let's just have our reactants be A and B, and our products will be X and Y. Okay, so let's think about what the greater than and less than might mean. So if we're at equilibrium, we're going to have some value where these are our equilibrium concentrations. If we end up with a bigger number for Q, what that tells us is that these numbers must be the ones that are oversized. In other words, we have more products than we probably should. So what's going to happen if Q is greater than K, then our reaction is going to run in reverse. Now if Q is less than K, that means that our bottom terms are now bigger than it would be at equilibrium. We have more on the reactant side than we do normally. Since we have extra reactant, that's going to drive the reaction forward. Now, memorizing this whole Q and K and greater than and less than, that can be a real pain, and it's easy to forget them or to flub them. That's why I recommend that you think through it with the logic that I just showed you. Just write down an equilibrium expression, think about reactants and products, say if Q is bigger than it should be, with K being what it should be, then that means it's going to do blah. If you use that sort of a logic, you'll be able to recreate these sets of rules on demand.